I'm Laurin, and today I'm going to talk about the ultimate GraphQL client developer experience. As you know, most of the developers love GraphQL, and today I will show you on why and how you configure your development environment and your tooling to get the best out of GraphQL if you're developing a client application. So first of all, let's have a quick recap of all the key features for client developers, or that client developers love about GraphQL. The first one is obviously the type schema. So any entity, any property that is available in your GraphQL schema is fully typed, and that is enforced via the execution engine before you get your result on the client. Then the second benefit is that clients only receive what they need. So if you have a user type that has an ID, a name, and an email property, but you only are interested in the ID and the name, and you don't care at all about the email, by writing a GraphQL operation, you can only specify that you're interested in this data, and then you will only receive that data. Also, in comparison to traditional REST APIs, a GraphQL endpoint is a graph. So you can also include relations of data within your GraphQL operation and then get all the data in one single round trip to your server. I have here an example that actually shows all those three benefits. First of all, on the left, we have our schema. Again, it's our type. We have an ID, name, location, best friend field. And then also we have our root query type that just exposes the me user. Then in our operation, we're actually selecting the me field. On that field, we're selecting the ID, name, and location. And then also what we're doing is we're selecting a relation, which is the best friend. And on those user type, we only select the ID and name because maybe our view that we are building only needs those properties to work. So there is no need to fetch all properties available on the user for our best friend field. So, and then the result will actually be predictable because we say, we define what kind of fields and what kind of data we want. And then within the result, we only will ever get those data, this data from the server. So in terms, the server now implements a new field, let's say the email field, and we don't update our operations, we will still always get the same result. So what this allows us as a client developer is to not be reliant on new fields added on the server, or be anxious about new fields added to the server actually breaking our application. So after I highlighted why we love GraphQL, let's dig into how we actually would consume GraphQL in a client application. So the simplest way, basically, if you're building a JavaScript application, is to just send an HTTP request using the fetch API to the GraphQL server. In this example, we're just sending a post request with the correct content type, application JSON, which is specified by the GraphQL over HTTP specification. And then in the body, we're just providing our query string that we want to execute against the GraphQL server. As we get our response, we will just call the .json method on it for getting our result. And then we can do whatever we want with this result. But most of you are probably not writing vanilla JavaScript code these days, because all of us are writing complex and big applications. And most of us also are leveraging TypeScript for getting better type safety. So let's have a look on how we would actually make this call to the HTTP endpoint with the fetch API type safe. So here again, we can see our query. We're the same as before. We select the me field on the root query type, and then we select the ID and name field for the user type. So obviously, the fetch call does not know what the endpoint will return. So what we would have to do here is to actually add an inline annotation because the JSON method call just returns a promise that resolves to any in terms of TypeScript. So what we can do is annotate this result assignment and then there inline our expected type. Obviously, this is not so scalable because in the future we will probably add new fields to our query operation. And every time we add a new field to our query operation, we need to sync the TypeScript types, adjust them, add new fields, and eventually they will get out of sync, and then you will have weird behavior within your application and nightmares. So in order to solve this problem, we have the GraphQL code generator that comes to your rescue. So to give a quick crash course of what GraphQL code generator does, it basically takes your schema in terms of SDL or introspection and all your operation documents, for example, query, mutations or subscription operations, and emits code or type definitions. So what you have to do is basically set up your GraphQL code generator file that you can do in TypeScript, by the way. Define your endpoint in this, your schema endpoint. You are just using the local HTTP server that is running in a GraphQL endpoint. Here you could also use your SDL files or even write a schema in line if you fancy. And then what we also need to do is specify where our documents are located via a glob. Here we're gonna leverage inlining our GraphQL operations within our TypeScript documents. And then we also need to specify what kind of output GraphQL code generator should emit. GraphQL code generator is capable of emitting a wide variety of code. You can emit TypeScript typings, type hooks for Apollo or Urkel. You can even emit C# code or Java code. But today we're actually going to focus on the client preset, which in my opinion is probably the best and easiest way of using GraphQL code generator within your application. So what we're going to do next after configuring GraphQL code gen, we're going to actually start it in watch mode. And that's all we ever have to do for GraphQL code gen. We just have to configure it, start it in watch mode, and then we don't have to care about it anymore. So next, we're going to jump into our TypeScript file. And then what we're doing is, as we initially ran the code gen command, it already generated a file for us, which contains a GraphQL function. And what we can do now is import this GraphQL function and then pass it our operation string for the GraphQL operation that we want to execute. And it will magically return a typed document that you then can use with any GraphQL client of your choice. For example, if you're into Urkel, you can just pass this document that's returned from the GraphQL function to your use query hook, and the result will be fully typed. In the same sense, you can also use Apollo client. Just the code is basically identical. You can also pass the document node there and also get a full type result. And even if you're like more exotic and using something like GraphQL request together with React query, you can just do the same. It's a bit more code, but the underlying principle is the same. So now you're probably wondering, okay, so what's going on? You just pass a string to a function and then the result's fully typed, and then I pass it to my GraphQL client, and then I have full TypeScript support out of the box without doing much. Let's explain a bit the underlying concepts that make this even possible. So there's actually four of those, and all of them are TypeScript features. So bear with me. I'm doing my best to explain them to you. So the first one is literal types. In TypeScript, there's a normal string type. So any string can be of the string type. But in recent TypeScript versions, there was a literal string type introduced. And that means that instead of a string type being just a string, it can be an exact string. In this case, for example, the exact string would be the query me with the selection of the ID and name field. The next concept is generics. And generics are basically like function parameters for types, and we're leveraging them for embedding a result type and a variable type in an existing type. So on the left, you can see that we have this underscore types property with a leading white space character. And why is this like that? Basically, we're trying to avoid people to manually access this property because it should only be embedded into a certain type for development purposes, for extracting the type later on. So as an actual user, you should never access this property. And then on the right side, we can see that we can actually use this helper type that we just created, for example, embedding a me result and a me variable type into a string. So that means that we then have a normal string type that we can pass anywhere, but in addition, it has some generics baked into it. So the third concept that we're using, and don't mind, I will put together all the concepts in a second, is function overloading. And basically, we're using function overloading for overloading the GraphQL function. So for every string that is within your project that represents an operation or a fragment, we define an overload function. And then based on actually what gets in there, we then know what type we need to return. So based on the literal type, we will return the correct string type, which has the correct generics baked into it. And then the last concept that is used within the actual implementation of the use query hook is conditionals. And basically, if you have a GraphQL operations, variables can be there, but they can also be optional. And what we can do is basically, depending on the variable types that is baked into documentation in a document, we can check whether it's actually variables or whether it's empty variables. And if the variables are empty, we can make the variables property optional. And if there are actually variables there, we can make them mandatory. And that means that the user will actually have a TypeScript error if he forgets to provide variables. So what? Okay, let's have a look at the code sample from before. So first, we have our string literal. We pass the string literal to our GraphQL function. Based on the string literal, the GraphQL function will then use the correct overload, because CodeGen is running in the background as you type, and will regenerate the file with the function overloads. And based on the correct match, it will then use the correct generic type and return it, which is then the me query document. And then in the last step, we pass the me query document to our client of choice. And within that, it's using generics and conditionals for actually extracting the variable and result types. And then when you are actually writing the application, you get the correct types and the full type safety out of the box. So if you're just a consumer of this, for example, you're using your Urkel or Apollo client, you actually don't need to care about all these concepts. You just need to run GraphQL code generator and benefit from it. So maybe sometimes you're actually using a specific use case where you can't use Urkel or Apollo client, and maybe you just are in a Node.js environment and you want to send an HTTP request to your GraphQL endpoint, but without a normalized cache and all the overhead of a GraphQL client, then you can also use those APIs, because the client preset is basically cross-platform. All you have to do is apply the patterns from before. So all the type magic happens through the definition of the execute operation function here. we pass it again a document that is the type document node, which has the T result and the variables embedded. And from there, we just extract those types and also return them. So that means that this client preset can be used with any JavaScript environment or any implementation. So as I said before, all major clients already have built-in support. So if you're using Oracle Apollo or GraphQL Request, you don't need to care. You can just start using it and it will work out of the box and it will feel like magic. So this unified way of using GraphQL code generator with different environments, clients, or frameworks reduces the configuration overhead and increases developer productivity. Because, for example, us as the guild, we have many projects with many different clients, and by just having a common setup that just works everywhere, we have less context switching, and it's nice. So the next thing I want to talk about is co-locating GraphQL documents with code. As you saw before, we wrote all our GraphQL operations within our TypeScript code, and I want to go a bit into why I think this is the best way of writing GraphQL documents. So first of all, we have less context and file switching, because if, for example, if you would put this query string into another file, then you have to switch to the GraphQL file, edit it, then switch back to this file. And also, we're co-locating our CSS code nowadays with the TypeScript code. Why not do it also with our GraphQL operations? Then also, you don't need to import your GraphQL operations from somewhere else, because you can just import the GraphQL function and write many documents in one file if you need to. And then the last, but in my opinion, most important benefit is that if you have this file and delete it, you also automatically delete all operations that are associated with this file. So in our experience, people that don't write their GraphQL operation documents within their TypeScript code usually locate them somewhere else in .graphql files, and then after a while, as your code base changes, and it will for sure, then you have some zombie operations laying around that are not actually used, but not really deleted as well, and there's no good way for detecting those yet. Also, the next thing that I want to talk about is how to configure your editor for a better IDE experience. If you're using Visual Studio Code, you should install this plugin now, because you just have to create this file in your project. It points to the same schema as our GraphQL Codegen config and points to the same documents as our GraphQL Codegen config. And what we get out of it is mind-blowing. When you're writing your operations, you will get full autocomplete for all the fields, for all your types. It just takes your GraphQL development workflow to the whole new level. So the last important thing that I want to talk about today is GraphQL fragments for describing data requirements, which in my opinion is a very, very underrated pattern that I actually saw very few code bases using so far. So let's give a quick recap what actually a fragment is. So a fragment is similar to a query operation definition that you have in your executable operation definitions. And it's a reusable selection with a type constraint. So in this example, we have our user avatar underscore user fragment that has type constraint on the user. And on the user type, it basically selects the ID and the avatar URL. And then we have our me query operation. And here you can see that on the me field, which is of the type user, we are applying the fragment by spreading it there. And then also on the friends field, which is a list of users, we also spread this field here. So if we would try to spread this on a type that is not of the on a field that is not of the user type, it would complain. So what this allows us, similar to how we write our query operations, mutations, or subscription operations within our TypeScript file, we can also write our fragment definitions within our TypeScript files and use it for defining component properties with those fragments. So in this example, I'm using the same fragment as on the previous slide. And what I'm using here is the same GraphQL function for generating the correct types. And then within the user avatar component, I'm using this avatar document type or node that got generated for specifying the user property. And then within this component, I'm actually using the fragment again for unmasking the data that got passed as a property. Because to the outside world or the operations or other fragments that pass the data to the user avatar, they won't have access to actually the fields that are only relevant to this one component. So what we can then do is on the next higher level, we can then reference the fragment and also import our component here because we want to use it. We can define our query document, declare our selection set, and then also, if we want to use the user avatar component here, we will just spread the fragment that we defined within our user avatar TS file. And also all those fragment names are now globally available, so we can use them in any file. And then we're gonna, just like before, call our use query hook with the document. And then we're gonna map over the result. And then the user avatar will get the user in. And within this user list component, you wouldn't have access to the ID and avatar URL field because they're actually masked on a TypeScript level. And then we pass it to the user avatar. And within those user avatar component, we can then actually access data after we call the use fragment function on it. So what's happening here behind the scenes is some TypeScript level data masking. And what it does is basically preventing you from accessing the data outside of the context where it should be used. And this allows you to actually build really scalable applications because you don't accidentally access data that is not defined as a data dependency of another component. And then you can do this for a single fragment or for a single component or fragment within your query operations, but you can also compose multiple fragments and components. And basically what I'm trying to tell you is compose GraphQL fragments like you would compose your UI components, because then you have really reusable entities and can build really efficient applications, because if you have like one query operation that references a full tree of fragments, then you only have one request that you're sending to your GraphQL endpoint and get back all the data you need for rendering your whole view. And the bonus on top is that all those fragment components that you define can be used on any route. You just have to add them to the component tree and add the fragment spreads to the specific query components. And yeah, so my conclusions here, or for you, for getting the best GraphQL client developer experience, is first to use GraphQL code generator for generating TypeScript, GraphQL operations fragment types with any framework or client library. And even if you're not using TypeScript, you should have a look at all the possible options you have with GraphQL code generator, because it's not only TypeScript. Then you should always use your editor tools and plugins to get a better IDE experience and improve your productivity. And then also you should consider leveraging fragment types for describing component data requirements. And last also use GraphQL fragments and operations for composing your UI components. And the best thing about this is that this is all already available. Like, we built this tool a long time ago and just got better over the years. From the community, we got a lot of feedback from our customers that we haven't got a lot of feedback. And even if you don't like anything, just open an issue or start a PR and help us make GraphQL CodeGen the best tool for doing GraphQL development. And also, last, I wanted to mention that we as the Guild have a lot of open source projects. We have a GraphQL Yoga server, which is a production-ready JavaScript GraphQL server with batteries included, stuff like caching, rate limiting, response caching, all of that stuff. Then we have also GraphQL Mesh, which is a library for composing multiple GraphQL schemas into a single schema. And on top of that, you can also convert your existing REST APIs or databases into GraphQL schemas and also adding to your GraphQL graph. And then also there's GraphQL Inspector, which is basically a CI tool, which you can use for ensuring that your schema and your operations don't break each other as you're making adjustments to your GraphQL graph or GraphQL operations. Thank you for joining and have a great day. My name is Laurin. Bye.